Sohcahtoa lesson. For math 3. So this is just right angle trig is what we call this. And we're going to use Sohcahtoa. So remember that this means the sine, the cosine, the tangent. So sine, cosine, and tangent. And it compares the angles. So this is sine of some angle. This is the cosine of some angle. And this is the tangent of some angle. To the sides of a right triangle. So this is the side opposite over the hypotenuse. This is the adjacent over the hypotenuse. And this is the side opposite over the adjacent. This is the most important thing you need to have in your notes every time you do an assignment on Alex. Okay? You need to have this written down, that the sine is the side opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. Of any right triangle, this only works for right triangles. So let's draw a right triangle. And we're going to draw one that everybody knows is a right triangle. So this is going to be an 8, a 6, and a 10. You can do the Pythagorean theorem. You'll notice that 6 squared plus 8 squared equals 10 squared. 6 squared is 36. 8 squared is 64. 36 and 64 is 100. That's the same as 10 squared. So that's just a normal right triangle, okay? Now we're going to start at this angle. We're going to call it theta. Oftentimes, especially on Alex, they call the angle theta. Okay, that's just a Greek letter that represents angles, obviously. So that's what we're going to use for our angle measure. So let's find the sine of theta, the cosine of theta, and the tangent of theta. You do not even need a calculator to do this, okay? Because you're just comparing the side lengths from the angle that we have chosen. So from this theta, we're going to do the sine of the angle theta. So I start from the angle. Always start from the angle that is given. So this is going to be the sine of theta is going to be the side opposite of the angle. So think about this angle. What is the side opposite? It's 6. Okay? What is the hypotenuse? Where is the hypotenuse? We talked about this last time when we were doing Pythagorean theorem. It's across from the loincloth, if you remembered. These are the legs on either side of the loincloth, obviously, and this is the hypotenuse across from the loincloth. So that's an easy way to remember it. So we're going to go, the hypotenuse is 10. Now you can reduce this and it'll be 3/5. But either one of these is actually technically correct, but usually they want it reduced on Alex. Okay? Cosine, very simple. Adjacent. Now a lot of kids mess up what adjacent means. Adjacent means next to. But the problem is next to this angle are both 10 and 8. So you have to be careful there and say, well, which one should I use for the adjacent side? The adjacent side is not the hypotenuse. Okay, so the adjacent side is next to the angle, but not the hypotenuse. So which one is next to theta, but not the hypotenuse? Well, it's 8. So this is going to be 8 over 10, which is 4 over 5. Tangent, going to tangent. Opposite over adjacent. So again, I start at theta. The side opposite is 6. The side that is adjacent is 8. Do not use the hypotenuse as the side adjacent. That's where people will mess up. So be careful of that. That reduces to 3 over 4. And you're done. That's pretty much all there is to Sohcahtoa. Now, we're going to do a few other little things, but it all deals with this principle. We're actually going to find the angle. So this is interesting because the sine of this angle equals 3/5. We know that. We've already figured that out, right? But how do we know what this angle measure is? Well, this is where your calculator use comes in. Now, if you're looking for an angle, you're going to use the second key on your calculator, or the inverse key, depending on how your calculator says it. And it's going to say above sine, so there's going to be a sine button on your calculator, even if you're using your calculator on your phone. If you turn your phone sideways, it'll give you this calculator with sine, cosine, tangent on it. And if you turn it sideways, you'll hit second or inverse sine, and it'll say sine to the -1, which is the inverse of the sine. And then you just simply put in 3 divided by 5. and then hit enter, and it'll tell you what the measure of the angle is. Make sure your calculator is in degrees. There should be a little DEG there. Make sure it's not in gradians, and make sure it's not in radians. Has to be in degrees. And you'll know, because this right here will end up being a degree measure. So it should be, think about this being 90. This one's got to be somewhere between, 20 and 40-ish, maybe a little more, but generally there. What did you get?
36.86.
So 36.86 degrees is what that angle is. Okay? Now what if we wanted to find this angle? Let's say we call this angle just x up here. Okay? What if I wanted to find x? Well, I could still use sine, cosine, or tangent. I just have to start at that angle. So for this one, let's just use cosine, just for fun, just to use something different. So let's say I wanted the cosine of x. So there's x. How would I do the cosine of x? Well, the cosine of x is actually 6, that's the side adjacent, over the hypotenuse, 10, which is 3/5. Only this time we're not doing sine, we're doing what? Cosine. So again, on my calculator, I want to find the angle x. Anytime you're trying to find an angle, you've got to use the second or inverse key. You got to use sine to the -1, or in this case, what? Cosine to the -1. So I'm going to hit cosine to the -1, which is second cosine on your calculator. And then I just put in that value, 3 divided by 5. And it'll tell me that other angle measure. What is it?
53.13.
Now I want you to notice something about these two angles, 53.13 and 36.86. What do those two add to? They add to about, now remember these are rounded, but they'll add to 90 degrees. How come they add to 90 degrees? Well, think about the triangle. This is 90 degrees. What do these two have to add up to? 90 degrees. Notice that the sine of an angle and the cosine of its complement, meaning the angle that would add to 90 with it, are always the same values, 6/10, 6/10. Those values are the same. And this cosine is the complement of the sine. Okay? All right, so let's do a little Sohcahtoa problem that you might see on your assignments then. So it might give you an angle. So let's say I had a ladder. The ladder's leaning up against this house. We're 5 feet away from the house. And we know this angle right here is 72 degrees. Okay? We know that angle is 72 degrees. And I want to find out how long that ladder is that's leaning up against that house. Can you do that? Well, yeah. What do you want to use? Now, this is where everything is super important to figure out whether you use sine, cosine, or tangent on any given one. So I look back over here to Sohcahtoa. So come back over here and look at Sohcahtoa. Oh, are you there? Okay, so look over here at Sohcahtoa. All right, and then look at this figure. We know this angle, so we're starting from this angle. What side do we know, and what side do we want to know? So think about that over here compared to over here. What side do we know compared to 72? It's the side adjacent. Oh, adjacent. So I'm either going to use cosine or tangent. That's the only one that uses adjacent. But I want to know the what? Hypotenuse. Adjacent over, hey, that's cosine. That's what I have to use. It is so, you can't just randomly just throw out something. Oh, I'm going to use sine this time. Oh, I'm going to use cosine this time. Oh, I'm going to use tangent. No, you got to figure out what to use. And you do that by looking at the angle, what you know, and what you want to know. So in this case, I'm going to write cosine of the angle equals the adjacent over the hypotenuse. Oh, sorry, I was going to write hypotenuse, but x. Okay? Now, how do I solve that? Well, very similar to other things we've done, we're going to cross multiply. We use this a lot in math, how to cross multiply. So now I just cross multiply this. So I have x cosine of 72, x times the cosine of 72 is what we're really doing there, equals 5 times 1. How do I get the x by itself? I divide by the cosine of 72. Now this time, are you finding an angle or are you finding a side length? You need to ask yourself that every time. If you're finding an angle, you're going to have to use the inverse key like we did here, second or inverse key. If you're finding a side length, do not use the inverse key. Do not use the second key. Just punch it in the way it's written. So I'm going to punch that in just like that. 5 divided by cosine of 72, and I'm going to hit equals, and then I'm going to get x. Now, before she tells us the answer here, think about this. Should x be bigger or less than 5? Obviously bigger. If it's not, I did something wrong on my calculator, right? So I'm going to hit 5 divided by cosine of 72, and it tells me
16.18.
16.2 feet, or whatever it was, okay, against that building. Pretty easy, okay? All right, let me give you another example. Anybody ever hear of OSHA? OSHA sets standards for safety, okay, generally speaking. So OSHA says, hey, we got these safety standards for landing an airplane, okay? This is what we call the angle of descent of an airplane. So here's the runway, okay? And here's the altitude that the plane is flying. This is how high the plane is up. And this is your angle of descent as it goes down, okay? So OSHA says for an airplane to land safely, the angle of descent of the airplane can't be any more than 2.5 degrees, okay? That's what it says. So let's say that we want to see if this is going to meet OSHA standards, okay? What we know is this. We are in the airplane, we're flying our airplane. Let me draw an airplane because you really need to have a good airplane drawing, and I'm excellent at drawing airplanes. All right, so we drew the nice airplane, good looking airplane, or hot dog based upon 2 other hot dogs, one bun a little smaller than the other, whatever. But we're doing that, and we have a right angle over here. We have a right triangle, so this tells us a lot. Let's say I look at my instrumentation on my airplane, and I say, hey, I'm getting close to the airport, and I'm flying at 1,000 feet. And my linear distance, meaning along the ground, this is your linear distance. So along the ground, hey, I'm going to say I'm about, I don't know, say 10,000 feet from the landing spot, okay? From where my wheels are going to actually touch. Is this angle 2.5 or big or less? This should be 2.5 or less. Let's find out if it is. How would I tell? Well, again, I want to think of this angle theta, and what sides do you know? Well, this 10,000 feet along here is the same as the 10,000 feet along here. So this side of the triangle is also 10,000. Now, this is the side what from that angle? The side opposite. What is this side? Is it the hypotenuse or the adjacent? Well, think about it. Here's the right triangle. This is the hypotenuse. I don't know that. But I do know the adjacent, so I'm thinking opposite over adjacent. Look over here. Which one is it? Which one is opposite over adjacent? It's tangent. So I'm going to take the tangent of the angle. I don't know if it's 2.5 or less. I'm hoping it is. So I'm going to do the tangent of the angle, theta, equals the side opposite, 1,000. That's all the higher I'm flying, 1,000 feet in the air. And I've got it 10,000 feet before I hit the end of the runway. So, by the way, 10,000 feet is about 2 miles, not quite 2 miles. So anyways, we're going to see if this is going to meet OSHA standards or not. Is this guy crash landing? Anything more than that is considered a crash landing. Or is he landing safely? Well, we're going to find out. Because I'm finding the angle measure. When you're finding the angle measure, you got to think, oh, wait, I'm finding the angle measure. I've got to use inverse tangent. Now, by the way, what you're really doing is you're taking tan to the negative 1. Tan to the negative 1 times tan is going to leave this as just theta. But this side also has to times by tan to the negative 1. So that's what I'm doing. I'm doing tan to the negative 1. I'm punching into my calculator 1,000 divided by 10,000. And I get what? So hit second tan.
5.71.
5.71 degrees. Is he safely landing his plane? The answer is what? No. He should have been at 1,000 feet long before the 10,000, at least twice as early as that, to get it down to there. So this should have been 20,000 feet. He should have been at 1,000 feet in the air. Okay? If he's going to be at 1,000 feet in the air, he better be at least 20,000 feet away from his landing spot in order to be safe, according to OSHA standards. So these are the things you're going to have to do. Either you're going to have to find the angle, which you're going to use the second key, or you're going to have to find a side length using Sohcahtoa. You've got to determine that based upon what you know and what you don't know. Now, by the way, you can always use Pythagorean theorem also. This is the last example I'm doing. So let's say I had this, and I had this being, I don't know, let's say it's 12 feet, inches, units, whatever. That's 12. And we did this one, and it was 7. Okay? And it wants to know the angles x. This is called solving the triangle. So I want to know angle x, angle y, and I want to know the side length x, y. Okay? Now, let's first do the side length x, y. Well, here you can just do the Pythagorean theorem. You don't even need Sohcahtoa. How come? Well, you have 2 of the 3 what? Sides. So I can do this. I just have to take 12 squared plus 7 squared equals, we'll call that xy squared. Right? Because that's going to be the hypotenuse. The hypotenuse always stands alone when we do Pythagorean theorem. 12 squared is 144 plus 49. 144 plus 149 is 193. And then I have to take the square root of 193. Can you do that for me? Square root of 193. You can guess it's going to be about 14-ish, but did you find it? Square root of 193.
No, I don't know how to do it.
Pause it. Oh, we'll restart it. All right, so the square root of 193 is 13.9 equals xy. So this is 13.9. That wasn't very hard. But I have to find these angles. Now, what do I want to use? Never use a rounded value. That'll always throw you off a little bit. I rounded that. Don't use that value. Use the 12 and the 7. They're given. Look at angle x. 12 and 7. How do they compare to angle x? 7 is the side what? 12 is the side what? Compared to x. Opposite over what? Adjacent. So I'm going to use opposite over adjacent. I'm using tangent. Again, don't just randomly always use tangent or randomly always use sine or cosine. Figure out which one is best. In this case, tangent is best. The tangent of x will equal 7 over 12. Now I just use my second key because I'm finding the value of x. I'm finding that angle. When you're finding an angle, use the second key, tan to the negative 1 of 7 divided by 12, which is
30.25.
30.25. That's that angle measure. 30.25 degrees. A couple ways to get y. I could just subtract that from 90 because it's got to be the complement. Or I could just do the tangent again of y, tangent because I know opposite over adjacent. I'm going to do 12 divided by 7 this time. Do the tan to the negative 1 of that. And y will be, now you could, it's going to be 180 minus 30 point whatever, so this is going to be what?
59.74.
59.75. You knew that this was 30, this would have to be close to 60 because that adds up to 90, obviously. So this is 59.75. So you could just subtract this from 90, or you could just simply take the tangent of y, opposite over adjacent, and you'll get the same thing. That's the lesson. Thanks.